I'm Michael Maloney, founder of Satellite Design for Recovery.
I'm Alistair Funge, Space Policy and Operations Engineer.
Hi, I'm Ralph Dinsley, known as Dins. I'm the Executive Director and Founder of Northern Space Security.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
And I listen to the Cold Star Project.
Welcome back to the Cold Star Project. I'm Jason Kanigan, the founder of this thing right here, Cold Star Technologies, a company that helps make other companies better by getting them insights through data science, machine learning, and process improvement. That means the way your people do things. The order in which things are done is really important to us. And by changing them around or eliminating steps, you can get what you need done a lot better. I am here with Dr. Moriba Jah. He is at the Odin Institute, isn't it, at the University of Texas at Austin. Very cool to have you back. This is your second appearance. And we're going to talk about space situational awareness and space traffic management topics that I was a complete newbie at. We were just talking about this before we got on the last time. Last winter, I think, or something like that, when we got on. And I wanted you back because I've learned a lot since then, and I wanted to dig deeper into some of these things. So folks, if you have not seen that original interview and these topics are new to you, I recommend go watch that. That will really lay the ground. We covered a lot of ground in that interview. We covered 6 or 7 high-level topics in the area. But thanks for being here, Moriba.
No, thank you. Pleasure to be back here with you. And this is definitely a topic that I'm passionate about, so that's always good.
Mm-hmm. Yeah, you've got a new podcast of your own that you're putting out. Tell us about that.
Yeah, so basically this is a partnership with spacewatch.global. They're headquartered out of Bern in Switzerland, and they have something called the Space Cafe series of like web talks, kind of webcast kind of thing. And anyway, Torsten and some others, they approached me and they said, have you ever thought about, having your own kind of, webcast series? I'm like, that actually sounds pretty good. I'd love to do that and basically find a way to just have some really candid conversations around themes related to like space safety, security, and sustainability. And so, yeah, so Space Cafe, Moriba's Vox Populi. It's Latin for the people's voice, which is near and dear to my heart. So yeah, I want to basically, select, 3 to 4 people, and for an hour just have a kind of a lounge chair. Let's kick our heels up and let's just like have a very candid conversation about topics that people usually try to hem-haw or steer away from.
Yes, there is a temptation in the space field to try and sweep this stuff under the rug. And I spent quite a bit of my time talking to regular members of the public in addition to space industry folks. And my favorite thing to do recently has been to send them to Celestrak. And, folks behind Moriba there's what might be a screenshot from something like Celestrak of your spheroid, shells of satellites. And it's always fun to watch them the first time that they see it, because you go to celestrak.com, trying to get Dr. T.S. Kelso on, by the way. We've been talking back and forth for months, but it'll happen. But he's a busy guy. And you load that thing up and it populates, and you see just the cluster around the Earth of all these space objects, right? And then nowadays I see this line and I'm like, oh, there goes SpaceX's stuff, right? All right. And then I ask them to back out. Use your mouse wheel and back out, and then they see the geo zone, right? And they realize there's even more than that. So there's a lot of stuff out there. I want to begin with a basic question here that will help us set the scene, I think. And it's a difference that I didn't appreciate the last time we talked. What I'm going to ask you to define, Moriba, is the difference between identifying, tracking, and then predicting satellite orbit paths.
Yes. So I guess a good way to say this, right, is that there are a number of things that actually drive motion of objects in space. It's the science of astrodynamics is what we tend to call it. And I would say any given object is probably basically exposed to four fields. One is gravitational, which I call an equal opportunity accelerator, because it doesn't matter what the size, shape, material properties of the object are. Just tell me where you're located, and I'll tell you what your acceleration due to gravity is. And then the other three are non-gravitational. We have radiative. An example of that is like solar pressure, photon flux interacting with surfaces of objects. The other one is particulates. So it could be micrometeoroids. It could be particles of atmospheric constituents for things in low Earth orbit. And then the last one is electromagnetic. These objects are interacting with a charged particle environment. They could be passively collecting charge, and then their motion through this magnetic field, they get this kind of Lorentz effect, this velocity crossed with magnetic field vectors, gives you this Lorentz acceleration. So those are like the four fields external to these anthropogenic space objects, human-made space objects. Now, all the non-gravitational stuff really depends on the physical properties of the objects, which we don't know a priori. Like, that's the thing that's really hard to figure out. So this is where the detection, identifying, and the tracking come into play, because we have these objects interacting in these four fields. Most of them don't report their identity. And if you want to be able to predict where these things are going to be, you have to understand how all these four field effects are going to impact these things, moving forward. And so first, in order to do that, you have a bucket of observations of stuff from like radars and telescopes. And then the question is, can you solve the identity crisis in the bucket of data of things that aren't reporting their identity, and say, okay, I've detected some stuff. Do I know, which object is which within the bucket of, non-self-reporting stuff? And if I can detect and identify these things, then this is what I call tracking, which is being able to maintain knowledge of where these things are, over time and space, or spatial temporally. And then, as a good astrodynamicist, as a good orbit determination analyst, from the data, can I infer these physical characteristics of the object enough to help me better predict all these non-gravitational effects that this thing might experience, because all of those depend on size, shape, material properties, and orientation. So from the gravitational perspective, I can represent all this stuff as like a sphere, which is what Space Command does. Every one of the objects in the catalog is modeled as a sphere, and there aren't many spherical objects. But then, even though gravity is a dominant thing, these smaller effects integrate into large errors over time. So if you just neglect the non-gravs, chances are you're not going to find this object again. So.
Okay, so there's our difference. So folks, there's no transponders on most of these things. It's not like the FAA where they can just look at a screen and go, oh, that's where that is. Nope, it's just flying around out there. And it's also modeled as a cannonball, which we covered last time, which as Dr. Jah pointed out, leads to errors over time, and that veering off between where you thought it is going and where it should go. I guess what we can dig into then is, what is the technology currently behind space traffic management? Like, I thought this was all taken care of before we first spoke last time, and then you discover it's sort of this duct tape technology from quite some time ago. So tell us a little bit about that.
I would say that state of the art in space traffic management is pretty horrible. It's definitely insufficient to meet the needs of this community, of this growing community of space companies launching stuff up there. I like to basically compartmentalize the space traffic management, and now people are incorporating the term coordination. So so some people are calling it space traffic coordination and management, but into three kind of threads. One is stuff related to space safety. Then you have stuff related to space sustainability and stuff, you know, related to space security. And in the safety stuff, so we have these three things. And so in order to actually achieve these three S's, space S cubed, as I kind of call it, we want to do stuff that A, makes the domain more transparent. I know what it is, who it belongs to, what could it do. B, makes the domain more predictable so that I can plan and all these things. And C, develops a body of evidence that can be used for decision-making and holding people accountable for their behaviors in space. So we want, you know, transparency, predictability, and accountability. Those are our yardsticks, or they should be. If we score ourselves with these yardsticks, we're not getting such a good grade in these things. And the grade is getting worse because of the absence of these kind of space traffic rules and that sort of stuff. For space safety perspectives, like an example could be, you know, collision risk. We don't have a rigorous way of even quantifying what the risk is of collisions. We use probabilities of collision, but there are inherent flaws with using probability as a unique metric to try to quantify collision risk. The other thing too is that, you know, part of being able to compute this collision risk depends on our ability to predict where things are going to be at some given point in time to within some uncertainty. So uncertainty quantification, there's a lot of work that still needs to go there. Most people represent the uncertainty as random. That's not really valid because a lot of the behavior up there is not random, it's just unknown. So we tend to call our ignorance randomness. And the thing is, that's not necessarily the case. And again, because we don't know all these physical properties of the objects, the prediction part for the collision risk becomes tenuous. Not only that, we have several companies that are operating in a similar orbital neighborhood. Each of them has their own decision-making criteria for when to move out of the way or when not to. This is also not something that's been standardized or agreed upon. And so, you know, I'm actually going to be interviewing folks from different companies to really try to get to what is the decision-making criteria that they have. Because in part of the prediction, it's not just dead objects on dead objects. It's how we predict that any two operators in a predicted near miss are going to behave. Will one of them say, oh, you know, it's just, you know, probability of collisions 1 in 1,000. So I'm just going to put my feet up and I'm just going to play chicken and wait for the other person to move because, you know, propellant is expensive. Or, oh, I was here first, so I shouldn't have to move. They're the newbie. They should have to. We don't have that kind of sorted out. From the space sustainability perspective, you know, one of the things that we need to do is really understand what is the carrying capacity of any given orbit regime. The European Space Agency has a concept of orbital capacity. I and some students are starting to pick that and see, you know, what else needs to be done to kind of refine that. But, you know, to be pragmatic, when I talk about the carrying capacity and it being saturated or exceeded, I would say that if we come to a point in any given orbital regime where our decisions and actions can no longer prevent the loss, disruption, or degradation of space services and activities, for all intents and purposes, we have exceeded the capacity of that orbital regime to carry traffic, okay? And so some people might say, well, that sounds like the Kessler syndrome. Yeah, okay, maybe you could say that. But so it's not just number of objects, right? But it's also the uncertainty with which we know where they're at and how well we can predict them in the future. And technology can actually add capacity, right? Just like with air traffic, the current air traffic in LAX couldn't sustain this air traffic, you know, 50 years ago. So with technology, we know where things are more accurately, more precisely. We can control things better. We can predict where things are going to be better. That adds capacity to the traffic, right? So these are the things that we need to quantify from a space sustainability perspective, so that we can actually use this in the licensing process. We'd love to do that, right? If somebody says, hey, I want licenses for 10,000 satellites in the next 5 years. Oh, okay. Well, you know, the carrying capacity of the orbit regime that you're asking the license for is blank. And by you having these 10,000 satellites, you would actually exceed the capacity by whatever. So the answer is no, or, you know, figure it out. Or, so we don't have that sort of discussion in the regulatory framework because we don't have the sustainability metric. And then the last one is from the space security perspective. People are just, you know, by and large, just looking at geopolitical saber rattling. Oh, Russia deployed this kind of thing in orbit, and it's an anti-satellite test, and we don't want to see that anymore. And China's got a space plane, and the United States, blah blah blah. And it's like, okay, so there's an arms race that is apparently developing in space. And people are kind of uniquely focused on that. You know, Eye of Sauron is on geopolitical dynamics. But what people are missing is that space commerce has a huge potential to also start conflicts, because any given domain of human interaction, especially one in which lots of money could be made or lost, every single domain, people have behaved maliciously. Companies will do things to other companies to one-up each other, to affect the other's bottom line, to blah, 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 especially if they know that the domain is mostly unmonitored and unregulated. So I would say space companies need to be observed extremely carefully if we want to be able to understand the space security issues just from space commerce. So those are that kind of gives you a lay of the land of, you know, what the needs are. And look, the largest public catalog is from US Space Command. It models everything as spheres. It doesn't model the physics as we need to be able to maintain this kind of knowledge to serve all these different needs. I would say that collisions are easy as compared to trying to figure out, okay, Acme Incorporated and Moriba Jah LLC have a dispute. Moriba Jah LLC says that Acme Incorporated schwacked his satellite when nobody was looking. What's the evidence, right? How do you reconcile these disputes? I look at Article 6 of the Outer Space Treaty that says states are responsible for providing authorization and continuing supervision of all activities of non-state actors in space. I see the US and other countries authorizing people, but continuing supervision, what does that mean? Does that imply that you know, the states that authorize know everything that the non-state actors are doing? I would think that that's what it implies, but that can be widely interpreted. So these are kind of where the big problems currently reside.
Yeah, these are real giant issues, especially the one of responsibility. The folks in England who we know have been running the space law games, and I think there's another set of people trying to find out that very thing. What does the process look like, and do we even have enough data to produce evidence that somebody's responsible for something or not? Now, typically, this has been done by the space monitoring has been done by the military, behind the military firewall. Civilians have not really had access to it except for the data coming out through, again, Dr. Kelso. And the Americans will say something somewhere, and the Russians may come up and say, no, our data says it's over here. And we're talking about the same object, folks. So it's not like there is super clarity on where each individual thing is. Now, I guess my next question is then, as far as precision in tracking and prediction goes, how good is good enough? What reaction time, because speed is reaction time and whatnot, what do we need in terms of precision, and how do we get there? What kind of mathematicians or physicists do we need to get involved at what level? And we're trying to bring this out from behind the military firewall into civilian usage so that a lot more of us can work on it. And I've talked to a lot of people all over the world, particularly in England, who are very excited about this possibility. What do we do?
Yeah, so my answer is multifaceted, as with most of my answers. So on the one hand, I'm going to say, I think that we need to look at things like traditional ecological knowledge, principles of TEK to apply to space, lead off with empiricism. We need to gather evidence of all the different constituents of the domain and understand the relationships between all these things. I think that we still, that requires science. So I think we're still not there yet. The other thing that another principle of TEK, I know these indigenous people have something to teach us, is the idea of developing norms of behavior. People talk about it, but we still don't have a pathway to that, especially in the absence of inclusive dialogue. So we need to kind of head in that direction, but we need to be transparent in order to, I think, get there, have mutual respect for different cultural differences that exist between the different actors in the space domain. So we need that as well, and some method of global kind of governance in terms of how to share and manage the resource, right? I mean, if we start talking about a space traffic footprint and capacity, that capacity belongs to humankind. It doesn't belong to a given country. So as soon as you start saying, hey, now I can quantify the capacity and what the space traffic footprint is of any given object, then it becomes more of a global dialogue that needs to happen, even in the licensing part, right? It's like, okay, can any given country take up all the capacity just because it's a first come, first serve kind of thing? Probably not, right? There should be some process to do that. In terms of, so I think, so there's part of it. The other part to your answer is, I told you these 4 field effects that drive actual anthropogenic space object motion, but I didn't tell you what drives our perception of the motion. So what drives our perception of the motion is A, the stuff that actually drives the motion that we will never perfectly know. B, our flawed physics. So the mismodeling of the actual physics also is part of what governs what we perceive the motion to be. The sources of information that we have at our disposal, okay? The actual sources of information, whether they be radar, telescopes, two-line elements, state vectors, blah, blah, blah. So all that. The assumptions that we make about those sources of information. And then lastly, we have methods of inference. Given the assumed models of how things are behaving and given the observations and sources of information, when we bring these things together, the methods that we use to infer the motion, those aren't perfect either. Different strengths and weaknesses, linear regression models versus, Markov chain, Monte Carlo type stuff versus like Kalman filters. Each one has strengths and weaknesses, and it's not a Lord of the Rings one inference method to rule them all. So all of these things actually influence our perception of this stuff. So there's a lot of uncertainty, there's a lot of error. So more work needs to get into shoring these things up, having a suite of methods that you test, because I believe, this is a computational problem, and to a great extent. If we can process the same data with different assumptions and a given inference method, okay, what's the answer there? Okay, now if everything's equal, if we do this kind of parametrically, what does the distribution of hypotheses look like, right? I think that's what we need, because that actually gives us feedback on what the landscape of error actually is. And nobody's gotten to that yet. So what we really need, when I'm telling you what we need, Jason, is we actually need to develop what I'm calling the space domain digital twin. So we need to develop a digital twin of the space domain, which is a virtual replica of what the space domain is.
Okay.
Yeah.
Mm-hmm. I'm getting a. Okay. First, let me make sure that I'm getting the picture that you're sending.
Yeah.
So when I first got into the idea of space around 2015 and that, I wrote some content which no longer exists. It was up on websites for a while and nobody cared. And so I just took it all down. But I was thinking, you know what we need to do? We need, like, for remote control of asteroid mining robots at a distance, they need artificial intelligence because of the communication delay to make decisions faster, right, on their own. Otherwise, they'll smash into the thing. And in order to do that, you've got to create a simulation of the asteroid and everything that it's near, right? So that it can do that close to itself, rather than having to send a signal to a brain somewhere else, wait for that to come back and then make the move or change or whatever it's supposed to do, right? So what I'm hearing you say is the digital twin idea here is getting that game world designer to come over and create a similar thing, but with all the satellites. Is that what you're saying?
Exactly. So
Okay.
so what I'm saying is yes, this is what my equivalent of the Holy Grail is for my work, and it's what I've been dedicating myself to for a number of years, and I just haven't used those words before. So the first time I'm saying that kind of publicly is here on Coldstar is we need to create a space domain digital twin, which needs to be a virtual replica of the domain, and it needs to have all the stuff that the space domain has, like, you know, all of the physics in terms of just the environment, charged particles, magnetic field, gravity field, solar flux, you know, all this stuff. So we can get a lot of that from NOAA's Space Weather Prediction Center. They have gobs of this. Okay, sounds good. So we can bring that in. Now what? Oh, now we need to do more than just bring in spheres and cannonballs. We need to bring in like actual 3D models of stuff. And oh, by the way, the thing's going to behave differently depending on my assumption on the initial conditions and how the thing's oriented and the little crinkling of the multi-layer insulation. And so you can kind of see where that gets complicated. And then, you know, and I think the FCC and other people that are licensing need to have this digital twin as well, because if we're saying there's going to be 5 companies operating in this LEO region, it's back to how do these people make decisions on when to move and how to move their stuff, right? And so that needs to be in the digital twin as well, because that's actually what's happening, right? How signals are transmitted and all that stuff, all that needs to be part of the digital twin. And even geopolitically and culturally, you know, given different political parties and their perception of the use of space, that might change. Even in the United States, between a Republican and a Democratic administration, the way we use space is not identical. So even that plays a role. That is part of the space domain. So that needs to be incorporated in the digital twin, given historically how different countries and parties have behaved and all this other stuff. So this is what actually needs to exist to really underpin how we do space traffic and space exploration and all these things. And yeah.
Okay, so I get it, and I agree with it, because I've done a lot of talking with folks over the last year about this subject. And of course, I came up with a similar idea myself, just not that big, not that grand, right? I was thinking local maps for dealing with this asteroid or something, but I realized you needed a simulation, right? So that's kind of cool. I may not be such a complete idiot after all. You can't afford to be second best. You need to be first, and that requires speed. Now, if you're thinking that growth is supposed to be slow and steady, frankly, the way I was taught back in the 90s in the operations management and business administration programs, you are too slow. We have to adapt. And in space, it's no different than anywhere else. People like to think they're special in space, and it is fun, all the stuff we get to work on, but Business is business. The fundamentals nowadays are conservative growth is not good. You need to run as fast as you can and risk outstripping your supply lines, which means in our world, using up the capital that we've got. That's a risk. But there is no prize for second place. There certainly is no prize for third. If you want to scale operationally fast, come talk to us at Cold Star Tech. We are the process experts for scaling fast. Now back to the interview. Oh, so for the past year, and especially with recent global crazy events, I don't want to say the word because YouTube penalizes, but I've watched this topic or this set of topics really ramp up in terms of being taken seriously. Like a year ago, a little bit more, it was almost shrugged off or laughed off, like, it's not that big of a deal. It's not an emergency. We don't need to deal with this. And I've watched, especially over the last 6-8 months, it start to get the attention that it deserves. Now, it's not nearly getting enough because it's still treated, I think, as an oddity or a, oh, that's interesting, you know, kind of level of thing. What do you think needs to happen so that decision makers, actors, regulators, politicians, and that around the world can get excited about this and get the energy to actually make change? Like, and funding, this is going to take money, right? The programmers, the facilities, the simulators are going to take money. And then I can hear Christopher Johnson at the Secure World Foundation all the way over here on the other side of the country, almost, you know, saying the United Nations is never going to allow that when you start talking about a global entity to manage this stuff. So what are your thoughts about that?
So a couple of things. Thing number one is I think we actually need to start focusing on how we need to go beyond situational awareness. We need to go beyond the domain awareness. So I think people are still stuck in, they're still stuck in yesteryear. And even though the military has moved from SSA to SDA, it's still not the right thing. I'm convinced that the right thing that we need to focus on, because I've said this for a long time, the only reason that we want the situational awareness is to make decisions. If there are no decisions to be made, who cares? And so decision intelligence is really what this is all about. Decision intelligence is it's a field that people at Google and that sort of stuff kind of created, which blends decision theory with social science, with AI and ML and all these things. And so I believe that what we should be focusing on is space domain decision intelligence, not SSA, not SDA, but space domain decision intelligence. And the funny thing is about this, Jason, that when I was, during my 10 years at the Air Force Research Lab, the US government was always trying to come up with a battle space management command and control for the decision maker. We want to enable the warfighter to make decisions. Okay, so who's the decision maker? And it's almost like the cartoons where it's like with Droopy that every dog takes a step back and Droopy's left alone kind of thing. It's like you can't find, you know, the military, they have all these people with many stars on their shoulders and that sort of stuff, right? And all the responsibility, you know, rests with, you know, general blah, blah, blah. But it's like, okay, when you go ask general blah, 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 you know, to make some decisions, the general is pointing someplace else. And it's like, you can't find a decision maker. I mean, decisions are getting made, but it's like nobody wants to embrace that. Nobody wants to strap on the responsibility of making decisions, which I find very funny and alarming, actually, about stuff in the DoD. I know that some people might hear that, they might not like it, but look, I looked for the decision maker as a researcher for a decade and I couldn't find a single one of them. But I will say that, on the other hand, I can find lots of decision makers in space industry because they got stakeholders, they got investors they got to answer to. You better believe that. I mean, hell, they've automated decisions about how to maneuver for the Starlinks, right? So the thing is, I can find decision makers in the commercial world. And so that's who I'm mostly working with in terms of getting to this decision intelligence. And what I'm trying to say is this: when it comes to decisions, I am really trying to not only train myself, but train others to pursue what I'm calling, I guess, data-driven decision making. And what I mean by that is, this is going to sound very Matrix-like. It's like when the Oracle, Neo goes to the Oracle and is looking for this guidance, and the Oracle is basically telling Neo that, you're not here to try to understand what choice to make. You've already made the choice. You're here to understand why you chose that. And so what I'm trying to get to is that we need to have choices or decisions pre-made based on criteria. And we need to be very honest with ourselves about that. Okay, I have this fleet of satellites. When would I actually get out of the way? If I get a conjunction warning 3 days out, and it's like probability of collision is 1 in 100, if I have no more information ever again, will I actually move out of the way? Like, let's be honest with myself. Maybe not. I still kind of think space is big, whatever it is, right? But it's like, let's list out all those criteria of when I would actually make the decision. Once you say, okay, I've been honest with myself, under these scenarios, my default action is to move out of the way. Then then you make a menu, like a restaurant menu. And then the only reason to gather data is to let you know which item you're ordering, right? But you're not gathering data and then it's like, oh, I have all this data. What am I going to decide? That's the wrong time to come up with decisions. So data-driven decision-making is you strap on all the different criteria for which you would make decisions. And, this is when I would feel comfortable. I need to be this confident and I need these sources of information. And once you get to that point, make your menu, and then the data scientists and the data analysts can give you the evidence you need to know which menu item you're ordering. That's where we need to get to for space domain decision intelligence. Not this, I'm gathering stuff and now I wonder, what am I gonna do? No, because that's dangerous, man.
Okay, that is a great vision update from you to me, hopefully to everybody else, because I haven't heard it quite put that way by you before. And I've had this, this is a data science company, so we're like, hey, what's the data lake? And let's do unsupervised learning on it. Let the computer tell us what it finds, right? And you're saying, no, well, let's go in with our criteria very clear, clean up whatever we can and make that visible first. And then choose our sources of data and collect or grab from that. And that is also different from what I've heard from a lot of folks in Europe who want that collective data pool of space data, and we'll scoop out what we want with our ladle and figure that out, So I've got some thinking to do about this and to see, I need to rejigger what's going on up here about it and see where I come down on that.
Yeah,
that's pretty neat.
So regarding like this whole data lake, which I see a lot of people really, the data lake is a data swamp. It's not potable water. I'm all about having lakes of potable water. So, but the thing is this: people say, okay, astrograph, seated by the U.S. government, blah blah blah. Aren't you kind of doing this kind of data lake-ish kind of stuff? And the answer is somewhat. Not only am I trying to collect as many disparate sources of information as possible because I'm trying to create a big data problem for myself, because that's when I can discover stuff, that might be hidden in the mutual information content of these disparate sources. But I liken it to a library, man. What I am trying to do is I'm trying to develop the space domain digital twin with all the models and stuff. At the same time, right, the sources of information to support that digital twin, call that like the space domain digital library. And much like a library is a place where people of all walks of life go. The millionaire that walks out of this really long expensive car is at the same place as the homeless person checking out a book. And you have children that go, and old people, scientists and artists. All of these people that are very different from each other go to a same location, and there's knowledge there for them. And in fact, two very different people might pick up the same book, but they're asking different questions. And so for me, where the knowledge resides, that can't just be based on who's asking the questions. I need to make that knowledge useful to anybody. And so it's my purpose to assemble the largest, most rigorous and comprehensive compendium of knowledge about stuff in space to support the digital twin, right? And multiple users can ask questions. I can get a policy person that says, who's compliant and who's not with geodisposal? And I can get some scientist that says, how many photons are being reflected off of these Starlinks because it's affecting astronomers? Those are two different users with two different needs, but the pool of knowledge has to be common. So that's the important thing. So when people say, oh, the lake and the ladle, to me, it's like a lot of people are doing what you're saying. And it's like, that's like the uber naive. These people really don't have a clue, what they're doing, to be honest with you.
All right. Well, again, it's all perception. It's very, very interesting. Let's conclude with a look at a specific technical piece of the puzzle here. I didn't know about this until, I don't know, maybe 6 months ago or something like that. Two-line elements, TLEs, and they're how satellite information about its location, spin, and all this stuff is sent back to the ground station. And then the countries monitoring this stuff can update their location for it and what it's doing in that. Why was the two-line element format chosen? And there's something wrong with it. I see people saying data is truncated, like you could actually get 5 lines of data sent, but they cut it off just to these two. Let's start from there and take it where you want to go.
So in order to understand the TLE, we have to go back to the beginning of the space age, to the Sputniks of the world and that sort of stuff, and to computers taking up whole warehouses and stuff like that. And so that's where this stuff came from, to facilitate computation and all that stuff. And perfect's the enemy of good enough. So what's good enough in terms of being able to point sensors? And by the way, when you don't have a lot of objects in the sky, not hard to do the identity thing. In fact, when Sputnik was the only object, I didn't even have to track the object, right? If I saw it, I knew exactly. That was a one-to-one causal relationship.
Right.
It's like, what? That's Sputnik. Now you have 26,000 things. There's more of a confusion matrix of stuff up there. Computers have progressed by and far, right, since then. But there's this thing called backward
compatibility.
Yeah, backward compatibility, right? And so the TLE has survived because there are still systems, hard-coded, that sort of stuff, in the field and that sort of thing, that require these things. And there's no way you'd have to upgrade or completely do away and start just fresh with a new system to get away from the TLE. So the TLE exists because of that. SGP4 is the theory behind the TLE, and it's basically averaged dynamic motion kind of stuff. TLEs are not useless. They do have utility. And I'll say that we treat them as the opinion of my cousin Vinny. So I have a cousin Vinny, and my cousin Vinny has opinions about stuff in space, and we tend to call his opinions TLEs. My cousin Vinny does a pretty good job at opining about the orbital energy of objects and their inclination. My cousin Vinny doesn't do so well with telling me exactly where in the orbit it is and how elliptical the orbit is. But my cousin Vinny does a pretty good job with orbital energy and inclination. So when we process TLEs within Astrograph, we actually have the math to process it as a human opinion and say, this is Vinny's opinion. Let's heavily weigh Vinny's opinion on energy and inclination. And the other stuff, we already know that Vinny's not so good at that. So don't weigh that as much.
That was great. Okay. I'm going to read something out of my note paper here because I want to get it right. Okay. So I was Googling along, doing my own research about what do we do about updating TLEs and that. And I found something called the Consultative Committee for Space Data Systems Blue Book from 2009, updated in 2012. I went to their website and I'm like, oh man, thinking's clearly being done on this topic, but why, from my perspective anyway, as an outsider, is the pace of change here so darn slow? It's just that backward compatibility issue, or
Yeah.
why haven't
right.
they decided by now to move on to something that gives them more information?
So the thing is, I think there's an and instead of an or. It's like people use TLEs and SP vectors and blah, blah, blah. So for the people that are stuck with just, I can only do TLEs, that's all they can do. I think more modern systems know how to take in multiple sources of information and recognize that the TLE is one of n sources, where hopefully n is a large number.
Okay. So other methods were limited by the technology that happened to be put into this satellite of what it can send and receive and that.
That's right.
Okay. What would you like to see happen next in this domain that we've been looking at? What would be like the yes, kind of result that's realistic and also exciting at the same time?
So what I'd like to see is more collaboration. I'd like to see more people come together to share information and that sort of stuff, even if it's just to demonstrate the possibilities of how that happens. There's too much lack of transparency, too much secret squirrel type stuff going on. Part of it, look, I mean, I'm not going to name the company, but I can tell you that there are a lot of people that are upset at a very specific company launching satellites. And, anytime this company puts information out there are people that are purposely trying to use it against them. Oh, we took in the information and we see that it's flawed and it's not good and it's not blah, blah, blah. So, occupying the time of lawyers to answer a bunch of stuff that really doesn't serve the purpose of making the domain more transparent, predictable, and holding people accountable, just because of, tits for tat. I think we're caught into a lot of that stuff now. I'd like to see more of that go away. That's what I would hope.
Awesome. Less selfishness, more global thinking here, or universal thinking, I guess is the right way of doing it. How can we benefit everybody and not just some sort of special interest group? Moriba, where can people connect with you if they want to? And I caution you, listeners, do not do this unless you are serious and actually want to provide resources or something. Do not. Moriba has enough draws on his time already. So
I would say this, right? It's like if you're genuine about wanting to do something with me, is just moriba@utexas.edu. If you want to get in touch with more ideas and these sorts of things, then I think just simple Google search, you'll see my webcast series, Moriba's Vox Populi, is out there, and sign up for that. It's free. And also, I have an op-ed column with Aerospace America and IAA called Johniverse, and you can find some stuff there as well.
Fantastic. All right, Dr. Moriba Jah has been my guest. Thanks for doing this.
Thank you, brother. Always.
Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Star Project. If you want me to send you new episodes of the Cold Star Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB. That's short for Make Space Boring, which is what we're all about. And drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Star Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks for listening, and I look forward to talking to you soon.